Hey guys, Mr. Shaw back at it. We left off right here talking about minimums and maximums. Let's talk about how to find them. So again, we know that the minimum or maximum is always going to be the y coordinate of the vertex. Okay, so again, in order to get this value, we have to find x using the axis of symmetry formula that we learned earlier. So again, we're gonna do a couple of these, but again, we need to find the y coordinate in order to figure out what the actual maximum or minimum is. So we're gonna find it, we're gonna tell whether it has a maximum or minimum, and then we're gonna find it. So in this case, we just basically this just means find the vertex. But so let's go ahead and get to it. So in this case, we see a negative for a. So again, here a is -1, b is 6, c is -1. So again, we know that this is going to be, it's facing down, so it's going to be a maximum. Alright, and now we need to find it. So again, we know our formula, x equals -b over 2a. So b is b is 6, so -6 over 2 times -1. So 2 times -1 is -2. So -6 over -2, which is +3. Now, in order to find what the maximum or minimum is, I need to find the y coordinate. So again, I'm going to plug 3 in for x. So it's going to be, I'll find f of 3, which is -3 squared. Again, be careful with how you write that. Plus 6 times 3 minus 1. So square it first. So 3 squared is 9, and then make it negative. So -9 plus 18 minus 1. -9 plus 18 is 9, and then 9 minus 1 is 8. So f of 3 equals 8. So the maximum value, the maximum value on the y-axis is going to be y equals 8. All right. And again, that's just if we had found the vertex and I had stated it like this, like 3, 8. You could have said just that the 8 is that maximum. All right, so let's do another one. That was bad. I don't know what's wrong with me today. Can't draw straight lines. Not better. Oh well. Here we go. Keep going. So I've got a is 1, b is 3, c is -4. So again, we know this is, again, it's facing up, so it's going to be a minimum value. And let's find it. So again, we'll use our formula. So -b over 2a. So -3 over 2 times 1. So that'll be -3 over 2. And now what we're going to do is we'll take this and we'll plug it back in to find the y value. So this one's going to be a fraction. It's going to be kind of gross. So let's roll with it. Let's do it. So it's going to be f of -3 halves. So we can do it like this. So this will be -3 halves squared plus 3 times -3 halves. And you can use -1.5 too. That actually might be easier. Alright, so let's go ahead and keep going. So again, distribute your squared to both terms. This will end up being positive 9 over 4 plus -9 over 2 minus 4. Let's just go ahead and convert all these to decimals. So this will be 9 divided by 4 is 2.25, and then -9 divided by 2 is going to be -4.5 minus 4. Alright, so 2.25 minus 4.5 is going to be -2.25 minus 4. So the y value then in this case will be -6.25. So that's what f of -3 halves is. So that's our minimum. Our minimum is, so y equals -6.25. And there you go. I know the fraction was kind of confusing, but again, it's the exact same thing. Again, you're just trying to find whatever the minimum is, and then we can actually use that to find the domain and range. So, and that's exactly what this says. Okay, I don't know why you don't even write that. Don't write this. Okay, we're just going to help. It's going to help us find domain and range. So let's do it. Now we know that the domain for every quadratic function is always going to be all real numbers. Okay, so again, we know that even like if it's facing up or if it's facing down, again, it's always going to go it's going to keep getting bigger and bigger. It's never going to stop. Okay, so that's going to always stay the same. So domain for every quadratic is always going to be all real numbers. Again, we'll talk about some interval notation, which would be negative infinity to positive infinity. Now again, if the vertex is a minimum, then the range is going to be, so now again, this is in set builder. So again, I want to just talk about it. So if it's a minimum, that means that the parabola is facing up. So what this means is that the range is always going to be, so whatever this value is, that's going to be the low point on the range. So you're going to use whatever this y value is, whatever this one is. Let's say it's just, I don't know, let's say it's C. We'll call it C. Okay, so this is C here. Okay, so again, it's always going to be greater than, it's going to be greater than or equal to the y value of the vertex. So again, it would be like I'm going to rewrite this. Y is greater than or equal to C, whatever that is. Or if you wanted to do it in interval notation, it would be from C, actually here, let me fix that. It'd be from C inclusive all the way to infinity. And hopefully the C is not confusing you. Again, it's just, this is in set builder, and we've talked more about interval notation than set builder, so I just wanted to make sure you guys are familiar with both. And then the last part is, again, if the vertex is a maximum. Okay, so again, if it is facing down like this, okay, and here's your vertex, and here's we'll use the same C value. Okay, if it's a maximum, then the range is going to be y, like all numbers that are less than C, so less than or equal to C. And again, in interval notation, again, you see like from here, it would be actually negative infinity all the way to C inclusive like that. So again, that'll give you guys kind of a better idea of what to expect there. Let's go ahead and do a few examples, and then we'll call it a day. So in this case, again, we're just going to find the minimum or maximum, and then we're going to state the domain and range. Okay, so let's do it. Again, so I've got A here, B, and C. So we'll find, let's do the vertex first. So negative B, so negative 16 is going to be positive 16. All over 2 times 4. 2 times 4 is 8. 16 divided by 8 is 2. Now again, we know that this is a positive, so this one's going to be a minimum because it's facing up. Okay, so again, that's my x value, and now I need to find the y value. So f of 2. So 4 times 2 squared minus 16 times 2 plus 3. 2 squared is 4. 4 times 4 is 16. Minus 32 plus 3. 16 minus 32 is negative 16 plus 3, so negative 13. So f of 2 is negative 13. Alright, so again, we know it's a minimum. Let me erase this A, B, and C business here so we know what A, B, and C is. So I'll state everything up here. So I know that the minimum is going to be negative 13. And now we can do the domain and range. So again, the domain for every quadratic is always going to be all real numbers or negative infinity to positive infinity. And then the range, again, it's a minimum. Okay, so that means it's facing up. So we're going to start at this value, so inclusive on negative 13, and go all the way to infinity. Now again, we know that because again it's facing up, so we start here at whatever this value is and go all the way up the rest of the way. Alright, and that's pretty much it. Okay, one more. So again, we know it's we got a negative out here, a negative 2 for A, so we know it's going to be a maximum, and we will find it momentarily. And B is 8, C is 7. So let's find it. So it's going to be x equals, B is 8, so negative 8 over 2 times negative 2. So 2 times negative 2 is negative 4. Negative 8 divided by negative 4 is positive 2. Okay, so now again we need to find f of 2 again. So it'll be f of 2 equals negative 2 times 2 squared plus 8 times 2 plus 7. 2 squared is 4. 4 times negative 2 is negative 8 plus 16 plus 7. Negative 8 plus 16 is 8 plus 7. So f of 2 in this case is 15. So my maximum is 15. And then, again, we'll do the domain and range. So again, domain is always negative infinity to positive infinity. And now the range, again, remember that this is facing down. So we're starting here at whatever value this is, and we're going all the way to negative infinity. So again, in that case, we need to start at negative infinity. So negative infinity to 15 inclusive. All right, and I think that's all I have for you today, guys. So I hope it's not too confusing. See you next time.